Everyone, this is Mr. Fugue and hope you're having a good day today. We are here on this video to talk about the second half of our angle addition postulate lesson, which specifically will focus around angle bisectors. So we're going to get started and then we have two quick examples. So this should be a pretty short video. So first I want to explain what an angle bisector is. I want you to think of this similarly to how we talked about midpoint during our segment addition postulate lesson. This is going to be a very similar lesson. We're just in the world of angles instead of segments. So an angle bisector is a segment or ray that will divide an angle into two equal parts. Now, alternatively, you could say instead of two equal parts, you could say it divides it in half, the bigger angle in half. I like the two equal parts better. So over here on the right, I have a diagram, and it says AC bisects. Let me get there's my stylus working. AC bisects angle BAD. We want to figure out what relationships we can make on this diagram at the right. So first thing I like to do is use my congruence marks, kind of like we did with midpoint, to make sure we identify what the two equal pieces are going to be. So in this situation, it would be this angle here, angle BAC, and then the other angle right here, which would be angle CAD. So a couple things to consider here in terms of setting this up. So right off the bat, I want to remind you that the angles, not start with A, we'll call BAC. I know I'm supposed to write little M's there. We're just going to skip over that for right now. I'll come back and add them later. So this first one is kind of what we already spoke about in the first lesson, and that is no matter what, if you have two adjacent angles to each other, when you add their measures together, you will end up getting the full angle. So this is the same thing as we talked about, part plus part equals whole. But just like we did when we talked about the segment addition postulate, we can look at just maybe two elements of this adjacent relationship as opposed to all three. So right off the bat, if we go back and use our idea of half equals half from the segment addition postulate work, then what we can create from this is the idea that the measure of angle BAC is going to equal the measure of angle CAD. So we can take each of the halves and set them equal. And then the last alternative we can look at here is we can take one of the halves, whichever half we have, double it, multiply it by 2, and that's going to equal the whole thing. So an example of that, there are two here we could work with. But if I take 2 times the measure of, I guess we'll say angles CAD, why not? And we're going to set that equal to the measure of the large angle, in this case, BAD. So just like with segment addition, we're going to need to make a decision on which of these three equation relationships will best serve us in our problems. So with that being said, let's jump into two examples. So the first one here tells us, well, it actually doesn't tell us verbally, but it is indirectly telling me over in the diagram, based on these congruent marks right here, that we actually have a bisector. So even though it's not marked, we now know officially that HF is going to bisect angle, what's that, EHG. So you don't have to write that, but I'm just declaring that based on the marking. So it doesn't have to verbally be told to you, it could be drawn in the figure. Now that we know that, we look at this, and let's use color. EHF is going to be the angle marked here in green. And then let me grab another color here. Let's go with blue for FHG. So when we look at this now, all right, well, we can easily, hopefully see that green and blue are separate adjacent angles. They are each half of the entire thing. So ultimately, what we're going to do is take the measure of EHF, which is 2x plus 10, and we are going to set that equal to the measure of FHG. So this is the half equals half situation that we want to use. So now let's go ahead and we'll do the algebra part where we solve this. So we get x, we'll subtract 10 to the right side, and right off the bat there we get x equal to 8. Now the last thing it's asking us to solve for here is to find the measure of EHG. So if we're going to go ahead and do that, well, we don't have an expression to plug in for that. But just as a reminder, EHG, since this is the whole, okay, keep that in mind, we can take one of the halves and multiply it by 2. So I'll take 2 times, and then in parentheses, we can actually find one of these. Pick your choice, x plus 18, 2x plus n, doesn't matter to me. But I'm going to go ahead and do the 8 plus 18. So I'm plugging it in, 8 plus 18 will be the half of it. So that's 26, multiply that by 2. We're looking like we're getting an answer here of 52 degrees. All right, well, we are down to one final example, so let's go ahead and jump down to it. If you would like to try this one out before I go over it, feel free to pause me right now, try the problem, and then you can play and watch my explanation. First thing we've got to do here is we actually have to create the drawing in this situation, so no drawing was provided. But I do have an angle ABC, so let's go ahead and draw that real quick. A, B, C, put the arrows on here, and then our bisector in this case is BD. So start the vertex B, go in the direction of the middle here, D, and remember that our congruence marks would then go here and here respectively. So let's go ahead and identify what we need to use in this problem. So we have ABD, so let's go ahead and label that in blue. I like really color coding this stuff, it really helps a lot. ABC, mark that across, and so what I see here is, okay, well, blue and green cannot be equal, but since blue is a half and green is a whole, then what we're essentially going to do is take 2 times the blue segment, or sorry, angle, and equal it to the entire thing. So this would be 2 times 8x minus 20, and then that is going to equal our whole here, which is 10x plus 2. So there is our setup, 2 times a half equals a whole. All we have to do now is the algebra behind this. So we're going to get 16x minus 40, 10x plus 2. I'm just going to do some quick algebra. Subtract 10 to the left-hand side. We're going to add 40 to the right-hand side. That's not going to be 40. It's going to be 42, remember. 40 plus 2. Divide both sides by 6. And there's our answer, x equals 7. Now, the last thing it's going to ask us here is to find the measure of BDC. Since we don't have an expression to plug in for that, we have to look at the information we have. Since ABD is a half and since BDC is a half, essentially all we got to do is figure out what this is. So it's going to be 8 times 7 minus 20. 8 times 7 minus 20 is going to give me 36. So it appears that the measure of angle BDC is just simply going to be 36 degrees. And that's that. So really, when it comes to angle bisectors, I want you to use the same mindset that we talked about when we did segment addition postulate and our midpoint conversation. The problems work extremely similarly. That'll conclude this video, so I hope this was helpful, and have a great rest of your day.